right, so I'm just gonna do a little bit of a demonstration for the lab that you're gonna do independently tonight, okay? So, or sometime today. So I have 3 glasses of water. These are just from my kitchen. Cold water, which I had ice in it, but I just removed the ice so that there's no solid floating around in there. This is just room temperature, and this was just water that was like all the way hot on my tap, okay? If you don't have glasses, you can also just use the plastic cups that are in your lab kit, and that will work just fine. Okay, so I'm going to use food coloring. If you do not have food coloring, you can use a dark colored juice also. Okay, so I'm going to add to the cold first. This is just blue food coloring. I'll just add 1 drop, and the room temperature and the hot. All right, and so what you want to observe through the condensation here is that there are slight differences in the way the food coloring disperses based on the temperature of the water. So you can see in the cold, it just kind of dropped straight down and settled. All right, the room temperature is moving around a little bit. It didn't make just one line down, and the hot is getting dispersed all over. Okay, so I'd like you to do this yourself, even though you've seen it here on screen, to see what happens. And if you you can use the little pipette that is in your kit. It looks like this, okay, to put in like cranberry juice or something, grape juice, something like that, that's dark in color if you don't have food coloring. So when we just look at the glasses, it doesn't look like anything is moving more in the hot, right? But it's because the individual molecules are moving more. Okay, so those water molecules have more kinetic energy, and they're going to bounce around more and bump into the food dye molecules.